Hey there, this video is a video demonstration, kind of a tutorial intended for BYU's ME471 class, talking about how to set up a model in HyperMesh, how to start an analysis in the HyperMesh preprocessor. Going over, this is a brief list of the steps that are required in HyperMesh to set up an optimization. Bring in your geometry, you mesh your geometry, you set up your materials and properties, then you assign your boundary conditions, that's being your constraints and your loads. You set up your load cases, and at that point you are ready to solve an analysis. But to do an optimization, you then go on to you add your optimization design variable, responses, an objective, and your constraints. So there are other videos which show some of the other parts of this, that namely setting up your properties, your load cases, and the optimization setup. But this video is intended just to show the parts highlighted in red here. The geometry, how to bring that from your CAD system and bring that geometry into HyperMesh, how to clean it up and get it ready to mesh, and then how to mesh your part, and then also how to apply your boundary conditions, your constraints, and your loads. Now this is definitely not the only way to do it, but this is one way to do these things, and we're going to try to make it as clear as possible so it's easy to follow. So here, this is my model. I have an NX, and for other CAD systems it should be pretty similar. I'm showing you this to show you the part that we are going to be working on. So this part here is called the shock mount, and it is attached to the differential here. It's bolted down, and then the other side is attached to our shocks. So this is the part that we'll be working on. This is the original geometry of the part. And so what we're going to do is show you the design space that has been created for that. That is visible in this part. So here is our that same model, the original part. But in this, when this was modeled, the workspace or the design space was also modeled, but just in this point it's been hidden or unchecked. So I'm going to show you what that looks like. So here is my design space model. As you can see, it's made up of several bodies. I have these bodies on the ends, 1, 2, and then these on the bottom, 3, 4, and that denotes our design space, or our non-design space. These are the parts that need to remain. We can't take away material from those portions. But then this big block in the middle is everything else that we can work on. So now it is possible to bring all of these parts already chopped up into HyperMesh, but there may be problems in the interface between this body and that body. HyperMesh, it's possible HyperMesh does not recognize that that's a shared face, and so when you mesh each of these bodies, the meshes won't be connected. It'll be two separate parts instead of one body, if that makes sense. So what we're going to do instead is we're going to unite this to be one big block, and then we will use the geometry editing tools in HyperMesh to chop it up. So I'm just going to unite this body. 1, 2, 3, 4. So now I have one big part, but to aid in our geometry as we chop it up in HyperMesh, we're going to create some lines here in NX and bring them over when we bring it to HyperMesh. But as far as this, we will probably just take this edge right here and chop it that way to chop up this piece. But for the ends, what we want is a circle that kind of denotes this top piece. So what I'm going to do is just make a sketch and draw a couple of circles. Okay, now I have this geometry here, and I want to bring it to NX, or bring it to HyperMesh. How I'm going to do that is export an IGES file, which is a neutral file format. Now, if you're using some other kind of CAD system, it should be pretty easy to figure out how to export an IGES file. In NX, you just say File, Export, IGES. And in other CAD systems, it may be a Save As. Maybe you'll save as an IGES file, or some kind of Export IGES. So in this, we will be exporting the displayed part, so everything that we can see, and we're going to call it this file. So I have that already by default where I want to drop it. So I just hit OK, and yes, and I just want to continue. And now it has created my IGES file. As you can see here, this is my IGES file that I just created. It's 2:24 p.m. And so to see if it worked, I'm going to open up HyperMesh here, and let's bring it in. So one way to bring it in is File, Import, Geometry. You can also get there by clicking this button, Import Geometry. And then it asks what my file is. So yours is probably going to be blank, so you hit Open, and you navigate to your folder that you have it in, and your IGES file, hit Open. So then it'll show it here. Then when you click Import, it'll actually bring it into HyperMesh. So here, it brought it in right. It brought in those lines that I wanted as well. This is a good way to test if you brought in the correct things of your IGES file. If it doesn't bring it in correctly, just go back to your CAD system, tweak it, the settings of the IGES export until you get it right. So now what we're going to do is we are going to get this geometry ready to mesh. So right now it actually brought it in as surfaces, not as a solid, and then it has these lines here. So we're going to make a solid out of the surfaces. You can do that through the geometry, and then solids right here. And then this one right here is bounding surfaces. So we select what bounding surfaces we want, and it'll create a solid in between. So surfaces, I'm just going to say displayed. So it'll grab all the displayed surfaces, hit create, and there now we've created a solid instead of surfaces there. The next thing we want to do is we want to cut up this solid into the different parts for design space and for non-design space. So actually with that, we have, as we brought in the IGES file, it brought it in as a component called level 1, so just some default component that it created. So I'm going to rename this, and let's call this one our design space. And we'll just make it green. And then let's create a new component that will store the geometry and the mesh for the non-design space. And I'll just make this one yellow. For now, I'm not going to assign a property or a material. We'll do that later. So hit create. So now non-design space is my current component as well. So let's cut this thing up where we need to, and then we'll move those new solid parts into the non-design space collector. So what we're going to do is we're going to say solid edit. We're going to edit the solid that we have here, and we're going to trim this solid with lines. Trim with lines, and then over here with sweep lines. So it asks me what solid do I want to edit, this solid, and which lines. So let's select this line here. What we're going to do is we're going to take this line and we want to sweep it along the Z axis and just cut everything along the Z. So we're going to say by a vector, and then we're going to set it to be the Z axis, and sweep all will just go from positive infinity to negative infinity along the Z axis and just chop everything that it touches. So we hit trim, and as you can see, it trimmed that, and that yellow denotes a shared face in between the two. So it is a common face in between these two bodies. We'll do the same thing. We'll select this solid, this line, Z axis, trim. So now we've cut that side, and then let's do the same down here. We want to select this solid and the lines along here, 1, 2, 3, but in this case we're going to want to sweep along the y-axis. So y-axis, trim, and now you can see it has sliced that, so it allows us to retain our non-design space there. And we will do the same with these. So here's our solid, here's our lines, 1, 2, 3, and there is our geometry. So now we have the different geometric bodies, but we still need to move them to the correct component. So to move things from one component to another, that is in Tools, Organize, and you can select what you want to move. You can move elements from component to component. You can move lines, surfaces, solids, loads, and etc. So we're going to be moving solids. So solids, and the destination component is non-design space, because that's what we want to move it to. And then we just select the solids that we want to move, and we say move. So now we have our geometry. This is our design space geometry, and this is our non-design space geometry. They're in their respective components. The next thing we're going to do is prepare this geometry for meshing. So we could mesh it now, but it's going to have a few problems. Let me point out the main one we're going to have. So every time you have an edge like this, it's going to snap nodes along the edge. Or in other words, it's going to make sure that nodes are placed along this edge. This face, it's going to place nodes along the face, but it doesn't really care where on the face it is unless there is an edge. So then on corners, that's obvious. It's going to put nodes along this corner, along this edge. But like, for example, this one, it will make sure that it puts nodes along this line that as it passes through. So as we look at this here, now here we have a corner, but we have two edges. We have an edge going here and an edge going here, and they actually, maybe they intersect. I think they do. But what's important is that it's going to try to put nodes along this edge and nodes along this edge, which is going to make some very small and thin elements, which is bad. We don't want that. So what we can do is simply toggle and turn off this edge. So on geometry, edge edit here on the right, one very useful tool is the toggle. So toggle, and we just simply left click on an edge and it will toggle that. As you can see, it's turned into a blue dotted line, which means it will no longer, when it meshes, it will no longer try and put nodes on that edge. So in other words, it's disabled the edge. So we're going to do that to both of these. So what's going to happen, it's still going to put elements or nodes along the face, along this surface, but it won't necessarily try and make sure it hits on the line. So some elements may kind of round the corner, but we don't really care. It's not very critical for our purposes. So I'm going to do the same over here. I'm going to toggle these two. Now here's something else interesting. You'll see we have an edge sitting here in the middle of this sphere, and it's not really necessary. We don't need nodes to be on that edge. So I'm just going to toggle that one as well. And over here. And some other locations. Here's another location where we see some. In the middle of this cylinder, we have, it's going to try and snap nodes along there. So for this case, I guess we'll leave it. You don't want to disable all the edges because the mesher could definitely it helps guide the mesher and where it should put nodes and how it should align things. But in some cases like these, those edges are going to cause bad elements. So now that we've cleaned up our geometry and it's ready to mesh, we're going to go mesh it. So these are the meshing panels. So this is for one-dimensional elements or lines, two-dimensional elements, which are flat, and we're going to do a three-dimensional element. We're just going to tet mesh this thing with tetrahedral elements. So it asks what volume are we going to mesh, and we want to mesh all the displayed solids. So all the solids are now selected. Trias and tetras is fine. So this is important. If this is set to elements to current component, then all the elements that are created will then be put into the current component. In this case, it would be the non-design space. However, we want it to be elements to surface or solid component. So the elements that are created from non-design space solids will be dropped into the non-design space collector, and those which are created on this solid, which is a design space solid, will be dropped into the design space. Make sure your element size is right, and that would be, you want to have enough refinement to accurately model to make just a good feel for it. But remember, the smaller your elements are, the longer it's going to take to solve your model, and it goes up exponentially fast in time required to solve your model. So you want to try to go as big as reasonably you can do. So let's mesh this thing, and here it's created this mesh. Now you have a chance to reject the mesh. This is the reject tool before doing anything else. So as long as you're still in this panel and you don't change anything, if you hit return, then you can no longer come back and reject or undo what you've done. If you change anything up here, if you go to any other thing, then you won't be able to. Basically, all you can do is look at it. You can pan and zoom. You can look at this and still be able to reject. I'm going to mesh it again. But once you go back, so even if I change the color, let's change the color of the design space to a lighter green. And now if I try and reject it, it tells me there are no entities to reject. So it won't let me do it anymore. So make sure before you move on that that's exactly what you want it to do. So here we have our mesh, our design space, the green, and our non-design space. I'm going to hide the geometry, so hide the solids to make it a little bit easier to see. And the next thing is we're going to create some one-dimensional elements now, because we're going to be attaching constraints inside these cylinders and some loads inside these spheres. but we need somewhere to put it. Instead of just attaching it to one certain node, we need it's better to create some RBE2s. So let's create a new component, and we'll call this one RBE2s, RBE2. We'll make this one, how about pink? Create. So by default, once you create it, it causes it to be the current component. So let's create one-dimensional elements, and what we're going to be making are rigids. Rigids and RBE2s are the same thing. So we're going to create these. So normally, by default, it's probably going to say this. You select one node and a second node, and it'll create an element in between. For example, from this node to that node, it creates a rigid element along there. Let's reject that. What you can also do is create from one, so here's our independent node, then you can select here and make it multiple nodes. So you can have one going to multiple, to 1, 2, 3, 4. Hit create. Now this is a single element, sometimes called a spider, because it goes from one to many, and that's what we want to do. And what further, if you're selecting multiple nodes, you can then say, instead of selecting where the independent node is, you can even have HyperMesh calculate where that independent node should be. So for example, on this, we're going to want to put, we're going to want to select all the nodes on the inside face of this sphere, and then have it calculate the center point of all those nodes and place the independent node at that location. So an easy way to do this is if you click on, you select one element from the face, and then say nodes by face, it will then pick all the other nodes on the same face as that one that we've already selected. So very quickly we've selected all the nodes on this face. And then once we hit create, now it creates a single element that is goes from this center point to all the other points around there. This is something quickly to note. So RBE2s have degrees of freedom, and you can have them all constrained, or you can have some open. By default, it's probably better to leave them all constrained. Sometimes you might want to open some up, but usually not. Okay, so we're going to do the same over here. We're going to create another spider. So let's select one node, nodes by face, and then just say create. And there is our center point there. So we'll put a load at that point. And then for these, let me show you another way to do it. Let's turn on our geometry again, our non-design space geometry, and let's do this. So now you can see we have our geometry and the elements that are constrained to that. Well, all of the nodes here are all on this face, this geometric surface, the outside surface. So what we can do is say the nodes by geoms, by certain geometries, and we're going to say surfaces. So it's surfaces, so it selects which surface. So we want this surface. So when we hit add to selection, it'll find all the nodes that are on that surface and add them to the selection, as you can see here. And then we hit, so now we hit create, and there's a spider. We'll do the same over here. Nodes by geometries, this surface, add to selection, create. Okay, now we have our RBE2s created. And the next step that we will be doing is putting on our boundary conditions. First we'll make some constraints, and then we will make some loads. So what we need to do first is create these collectors. So create the load collector, and we'll call this one SPC, and we'll just make that a blue. And make sure the card image is set to none. And create, and then I'm going to make a second one called loads. And we'll make that one red. Okay, so now I have my two load collectors. Let's make the SPC one current so that we'll create these constraints and it'll drop them in the SPC load collector. So we're going to put constraints at these points. So this is where in our structure from our model, this is where this part is bolted to another part. So there's a screw that goes through here. So what we're going to do is we're going to constrain this in all the degrees of freedom on each side. Just lock it down completely. So to get to constraints, we go to analysis, constraints, and we're going to create a new constraint at what node. We're actually going to select both nodes. So both this node and this node we will have constraints, and we want all the degrees of freedom locked down for this scenario. So this is something you're going to want to think about. How is this, what would be the best way to accurately set up this simulation to try and simulate how it really is, the real loading condition. And then we will, once we're done with that, we hit create. And as you can see, size, this, you can change the size of the loads, or in this case the constraints, and this doesn't affect the analysis at all. This is purely for making it easier to see where your constraints are. So our model is constrained in those two locations. Now let's put some loads on. So let's make the loads container current, and then we will go to analysis, forces, and then so now it's asking which node do we select. So let's do this one here first. So we want to have a load that goes through this point, and if you remember, the shock absorber that's attached to there comes in at an angle. So let's say that we've calculated this to be, we could tell it what vector to do, or we can just give it its x, y, and z components. So if we say that is from constant components, so we can say constant vector and tell it how much and in what direction, or constant components just tells us how much x, how much y, how much z. So in this case, we're going to say 20 units of force in the x direction. So 20 in the x direction, 50 in the z direction, and 5 in the y direction. So we have that node selected, and we hit create, and there is our force showing how big the force is. And then we will do the same, create a force on this side, and we'll make that but in this case we want to have -20. That way it'll point the other direction in the x direction. Hit create, and there we have it. So now we have our mesh, we have our constraints, we have our loads. What's next in this? So let's look at this again. We have created our geometry, we brought it over, we've meshed our part in design space and non-design space, and we've put the boundary conditions on constraints and loads. So what's left next you would put materials, assign materials to your properties, and assign your properties to your elements, and this is shown in the next YouTube video with the bridge. And after that, then you would set up your load steps and set up your optimization and solve. And these, once again, these things are shown in the video, another video posted for this class, the one that has a bridge. So it won't be the same model that you'll be seeing, but it will be the same principles that you will apply. Where the next video starts is where we end here with geometry, mesh, and boundary conditions.